In this video, I'll help you unlock the math skill area of a trapezium. For many students, this is the trickiest formula in the entire area topic. To master this lesson, I'm going to show you two simple keys, which are the exact pieces of information you need to make this skill feel easy to learn. I've refined these keys over 10 years of teaching, and once you understand these keys, the formula becomes much easier to remember. In this section, you will learn where this skill is used in the real world and what is a trapezium. Imagine you're helping design a new skate park. One of the platforms looks like this. Before the skate park opens, a special non-slip protective coating needs to be applied to the entire surface. This coating helps riders stay safe and gives the platform extra grip. But before workers can order the coating, they need to know how much surface needs to be covered. But there's a problem. This shape isn't a rectangle. It's not a triangle either. So which area formula should we use? Neither formula seems to fit this shape. So how can we work this area out? Well, this shape is called a trapezium. It's a four-sided shape with one pair of parallel sides. So if we find the area of the trapezium, we'll be one step closer to calculate the amount of coating needed for the platform. In this section, you will learn what the formula is and how it was discovered. Similar to triangles, counting individual squares inside a trapezium isn't very helpful. Many of the squares are cut, so there must be a better way. Here's the challenge. Can we somehow turn this trapezium into shapes we already know how to find the area of? Take a moment and have a look. What is the best way to break this up with the least amount of shapes? The best way is draw a diagonal from one corner to the opposite corner. Now the trapezium has been split into two triangles. Let's call them triangle 1 and triangle 2. And that's exciting because we already know how to find the area of triangles. Area of a triangle equals half times base times height. So let's see what happens if we find the area of each triangle separately. Let's start with triangle 1. Its base is this side. We'll call that length B. Its perpendicular height is this distance here. We'll call that H. So the area of triangle 1 is half times base times height. Now let's look at triangle 2. Its base is different, so we need a different letter. Let's call this base A. What about the perpendicular height? Look carefully. The perpendicular height of triangle 2 is exactly the same as the perpendicular height of triangle 1. Both heights stretch between the same pair of parallel sides. So its height is also H. That means that the area of triangle 2 is half times A times H. Now for the important step. How do we find the area of the entire trapezium? We simply add the two triangle areas together. Area of the trapezium equals the formula for triangle 1 plus the formula for triangle 2. At this point, we already have a formula that works. We could stop here and calculate the area of the trapezium. But mathematicians love making things simpler. Can we write this as one shorter formula? Look carefully. What is common in both terms? Both terms contain a half and the H. So we can factor those out the front, which leaves a half H and in brackets A plus B. And there it is. If you are rusty on this skill, this is the algebraic skill of factorizing. Now we've just discovered the formula for the area of a trapezium, not by memorizing it, but by building it from formulas we already knew. Let's summarize. Whenever you use the trapezium formula, you need three measurements: the A, the B, and the H. The values A and B are always the pair of parallel sides. The value H is always the perpendicular height between those parallel sides. Be careful, the height is not the sloping side. It must form a right angle with the parallel sides. You may also see the formula written slightly different ways. I like this version since it reminds me where the formula comes from, the two triangle formulas. 1/2 times the two bases times the height. All of these are the exact same formula. The order changes, but the answer does not. So whichever version you see in the textbook or exam, they'll all mean the same thing. You now know all the key information on this concept. However, can you solve all exam style questions? Watch this next video to master questions easily.